Okay, so here's this deep neural network I created that classifies handwritten digits. So I just started off here with those are all my libraries that are declared. This mp.random seed right here, this is just creating the random points. And what this seed.0 does is every time it showed, instead of creating like every time this is run, instead of doing different random points every time, what the seed0 does is it's just seeding the same points every time. And then we have our test and we have our training data. So for this, I used the softmax activation function, considering that we were classifying between multiple different classes, and I used cross entropy. So yeah, that's pretty. I forgot where I was gonna go with that. Okay, so this right here, what this is what these two for. This is number of columns, number of classes. I think that's slightly self-explanatory. But what this is doing is I created a 2D dimensional arrays, which is displaying all of my numbers. These are just numbers the people have drawn. Then I have 0 through 9. And what this does is it prints out the two-dimensional array. And then this is the training data set distribution. And so this is between the classes and the images. And then we are categorizing. Okay, so I use the softmax activation function, and what that is doing is when you use the soft class data function is for when you have multi-class data sets, like for this example where you have all the different numbers. So the thing about that is relative magnitudes have to be maintained, and all of the probabilities have to add up to 1. So what the softmax function does is it takes your probability and it adds, basically it's adding them all up to 1. So let's say we have our input layers, and then they're going through our hidden layers, and then at the end when we're given an output, that output is being converted into our probability, and then all of those probabilities have to add up to 1. Okay, and also if you can see, I have my graph right here. So basically, it has a small training error, and the gap between the test and the training error is getting smaller. So to ensure that the training error is getting smaller, that's when we're generalizing the data. We don't want to memorize. We're not memorizing patterns. We're not memorizing specific things. We need to just memorize. We need to create a general pattern for the number. So we're not memorizing like specific pixels and all that kind of thing. So how to do this? We have to make sure that we're not underfitting our data or overfitting. And how overfitting can work is if your complexity is too high, if your capacity is too high, and how that can happen is, again, if it's too complex, if you have too many layers and overfitting, then you can again have that error. And then you can have the opposite, which would be underfitting, which is a small range error, not enough layers, and the more hidden layers, the more complex your network can get. And so for this, I was just plugging in for I ended up using 10, and it doesn't have that many layers. And then this is just right here for these arrays. This I drew this image too, and then what I had to do is I had to use the CV2 library, the OpenCV library, and then convert this into grayscale. And basically, I just used the bitwise operator to just flip this black and white. And then I just have it printing. It's just printing out all the pixels right now. So this is the digit that I fed into my neural network, and it's trying to classify it right now. And it classified it as 2, and I was in the middle. Okay, so the more hidden layers you have, the more complex. And if you want to reduce the complexity of your network, this can easily be done by reducing the depth, reducing the number of nodes. You can reduce the number of epoxy, which I don't think is very high for me. Anyway, so I don't think it's really... Yeah, I think we're probably pretty good with epoxy. and you can also use larger data sets. So again, I use cross-entropy in this model, and just a little review for what cross-entropy does is it takes the natural log of the y value of all the points, and then it adds them all together, and yeah, it takes the sum of that, and then it takes the negative sum. My bad, misspoke there. Okay, and then so for since this is a softmax, this used where was it? Can't remember. Okay, so this used a softmax function, and I used hyperparameters. So hyperparameters are used to control the behavior of the learning algorithm, and can configure the complexity of the model. And so what I guess I could explain first what hyperparameters are. So hyperparameters are the learning rate, the number of nodes per layer, the number of hidden layers, and the depth. And again, this just goes general to say for all neural networks. The deeper your neural network, the higher learning capacity. But again, you have to keep in mind overfitting, underfitting, all of that stuff. And if your rate is, again, too high, you have to deal with overfitting. So for validation sets are sets of examples used to fine-tune your hyperparameters. So again, like number of this stuff, number of columns, the training, that stuff would be referred to as hyperparameters. So I have my training, I have my test, and I have my training data sets right here. So you use training data set to learn your standard parameters, and then you use your validation data set, so that would be like our test data set, to fine-tune the hyperparameters. So again, what this is trying to do is, we're not looking pixel by pixel by pixel, we're trying to create that general pattern. And that's what all of this has to do. So you go from your training set, and your training set is usually 3 to 4 times larger than your validation set. So you'd go from your trainings, basically you'd go from your training set to your validation set, and then to your test set. And now your training set and your validation set, both of those things have an effect on your model. Your training set has about a 90% of effect on your model. Right here. Yeah, I was gonna have these errors thrown right here, but I just took that out because it wasn't really that important. Man, my hand's kind of starting to hurt from holding my phone. I don't know why I didn't just use screen recording. But and then training set has a 90% effect on your model, and then the validation set has roughly 90%. These are just all kind of estimations. While your test set again has 0 effect. So if you can't see this model, I think I showed earlier, this is currently working. The 2, and then I have my predicted digit right down here too. Awesome. Thank you for watching, and yeah, this is just a deep neural network model that I just created over the weekend. Thanks.